Okay, so solution, suspension, and mixtures. This is another term that we learned back in physical science. So I just got done talking on your previous video about bonding and ionic and covalent bonding and the chemical bonds. So we're going to take a shift now into this and then into water and all the properties of water. So if you remember, mixture is when I put a couple things together, could be more than a couple things, but then there's no chemical bonding between them. The elements haven't changed. So if you remember, I said with NaCl, table salt, one is a poisonous gas, one is this silvery metal. I put them together, it makes table salt. There's a chemical reaction. Well, when I have a mixture, there is no chemical reaction. I've just put stuff together, and I could probably, or excuse me, I can most of the time pretty easily separate it. Okay, so what are some examples here? Salt and pepper, easy mixture. Sugar and salt, easy mixture, although they're both white, so it might be kind of hard to separate them. They can be separated, but it does not alter the chemically alter the substances. Excuse me. All right. Now, when we get to mixtures, well, there's a couple of types of mixtures that we want to look at. The first one is a solution. Now, a solution is still a mixture, but a solution is when something has dissolved into something else. All right. So if you think I'm going to have a glass of iced tea, I like my tea sweet. So if I take my tea and I put sugar in it and stir it up, the sugar has dissolved, right? I can't see it, but I know it's there. Why do I know it's there? Because the tea tastes sweet, right? So since the tea tastes sweet, I know the sugar's in there. It hasn't disappeared. There's been no chemical reaction that has changed the sugar into something else. It's simply just dissolved, basically spread itself evenly throughout. So again, some more examples here. Salt and water. Now, the parts of a solution are very important for us as we go through these next few videos and concepts as we review chemistry. So first of all, you have the solute. The solute is the substance that is dissolved. So when I put my sugar into the tea, the sugar is the solute. It's the stuff that's going to look like it disappears, although we know it doesn't. The solvent is the stuff that the solute is dissolved in. All right. So in my iced tea example, I'll keep coming back to that. I put sugar into the tea. The sugar is the solute. The iced tea is the solvent. Now, in most solutions, water is going to be the solvent. Okay. We call it the universal solvent because most things dissolve in water. And we'll talk more about that when we get to water. Well, there you go. Water is very efficient. And I'm sorry that the bell is ringing. Because it can dissolve both positive and negative solutes. And like I said, we're going to talk more about that when we get to water. You can have different concentrations of solute and solvent. Basically, what that means is how much solute is dissolving in the solvent. Okay, so the more solute I put in, the higher the concentration goes up. Okay, so my example here, 2% saltwater solution. I've dissolved 2 grams of salt in 100 milliliters of water. So basically I can do a little math. 2 divided by 100, that's 2%. It's a very low concentrated mixture or solution of salt water. Saturated solution is when you have so much that you cannot dissolve anymore. We actually did a lab in physical science last year where we kept adding sugar and kept adding sugar, or maybe it was salt, excuse me, and seeing to the point where it would stop dissolving, where it would just kind of settle down to the bottom. That's when it became saturated. All right, so that's a little. That's when there's so much solute that no more will dissolve. Think of your yard when it rains, when there's a really big storm. Sometimes your yard gets saturated. Here's what I mean by that. If you go out in your yard and you feel soggy, like you can take a step and you feel like you sink in, well, your yard is completely saturated with salt, with water. It has filled up every bit of lawn and dirt and space in your lawn, so it's become saturated. Same thing with the solution. Uh-oh, my clicker's not working. There we go. An aqueous solution, this is going to be important for us because we're going to talk about acids and bases. Any solution where water is the solvent is an aqueous solution. Okay, that term is going to be important for us. Aqueous solution, wherever water is the solvent. My salt water, okay, my iced tea, We're going to talk about acids and bases. We're going to make aqueous solutions when water is the solvent. Then I have a suspension. Well, what's a suspension? Basically, where I put two things together. Remember, a solution is a mixture because there's no chemical reaction. Suspension is also a mixture, but when I have a suspension, there's no dissolving taking place. My favorite example of this is Italian dressing. If you've ever seen a bottle of Italian dressing, when you just let it sit there, all the stuff settles down to the bottom, and it looks kind of weird. But then I take it and I shake it up as hard as I can, and all those particles are moving around. But you can still see the particles. No dissolving has taken place. All right. So my suspension is when there is no dissolving, the solutes don't dissolve. I still have a solute, I still have a solvent, but there's no dissolving that is taking place. So what keeps those things suspended or moving around? It's movement. But if I set that Italian dressing bottle down, leave it there for a day, guess what? All those things are going to settle down to the bottom. Okay. So solutions and suspensions. In physical science, we talked about another mixture called a colloid. We're not going to worry about that here with biology. We're just going to worry about suspensions and solutions as part of our mixtures. Now, this video here, I'm not going to play it right now. I want you to watch it. The science of macaroni salad and what's in a mixture. Really funny video here about the things that go into a mixture and solutions and suspensions.